Okay, so that first video got cut off, and we're going to pick up with it here as to what we were doing. But that's okay. We had to do, or we're needing to do a second video anyway to talk about this second notion of radian measurement for an angle, which we'll get to in a moment. So in that first video, we just reached the part where we were doing this last example here, where we were finding arc length of AC. And again, just to walk it back through, what we said was, okay, if here, let's see, here's number 5, we're looking to find arc length of AC. What we do is this part over whole. So we say 70 over 360, that's the arc measure based on the central angle, divided by 360 degrees total in the circle, equals part over whole. So part of the outside divided by the whole of the outside, and that is right here. So 70 over 360 is part the AC divided by the whole circumference. We said we found the circumference to be 18.8. We said, okay, let's find out what the arc measure is. And the only thing we had left to do, and where we got cut off with the time limit on the last video, is just to multiply both sides by 18.8. And that is going to give us our measurement for our side AC. So we'll do 18.8 times 70 divided by 360. And we're just going to punch that into our calculator. So we would do our 18.8 times 70 divided by 360. And we hit our enter. And it's going to give us 3.65, so we'll call it 3.7. So there's 3.7. And 3.7 should make some sense in terms of what it is we're trying to find. The entire distance around the outside, the circumference, the whole thing was 18.8. We're just doing a little piece of it, a 70-degree piece. That should then be smaller than the 18.8, which 3.7 is obviously smaller than 18.8. And the way you figure out how much of that smaller amount you're using is you use this idea of part divided by whole. So you say, well, what is 70 over 360 as a part over a whole, and then compare that to the arc measure or arc length over the circumference. And the reason that comes into play, or why that ties into what we're going to be talking about in this video, is in this video we're going to go back up. So I'm just scrolling back up through the notes we took. So this is on that second page of the notes template. We skipped this idea of radians and degrees. Degrees you're already familiar with. That's an idea you know. Radians is just a second way to measure an angle. So the radian measurement is the second way to measure an angle. And they give you a couple ways to find it right here. I'd actually like to propose a different way of thinking about this. It uses the same idea. And these are both true, so these are both good things. They're both true and they both work, and we'll do an example with them. But what I want you to do instead is just think about a circle. So if we've got a circle, total degrees are 360, so 360 degrees total. And that's just deciding that way long time ago, when mathematics foundations were getting laid down, it was just a decision was made that we are going to split a circle into 360 little pie pieces. And however much each of those little pie pieces opens, we're going to call that 1 degree. And we're going to make it so there's 360 of them in there. That's just what it means to be a degree. A radian measure is just a different way to measure an angle. And the way you're doing, so total, I should write total degrees. The way radian measures get used is it's how many radiuses. So if we were to take a radius, I'll use a different color. There's our radius. If we were to take that radius and make it bendy, how many of those could we lay along the outside of the circle? So how many, if we were to just take that, took a spaghetti noodle type thing that was cooked, and you could bend it and lay it around the outside of the circle, how many of them would be out there? And it's actually not that hard of a number to find. So you think about, well, how many radius lengths could fit around the outside? Well, what is the length of a circle? The length of a circle is 2 pi times the radius. So how many radius amounts fit around a circle? 2 pi of them. There are 2 pi, or 6.28 approximately, radius lengths you can fit around a circle. In other words, if we took that red line and we made it bendy, we could fit 1, 2, 3, 4, 5, 6, and then a little bit more. That's how many radiuses, if you could make them bendy, would fit around the outside of a circle. And that's what this circumference equation is saying. It is saying the circumference of a circle is 2 pi r. So if we chose to measure the angle as a radian, What that means is how many radius lengths could we fit around the outside. Another way to think about that, and I think something that a lot of my calc students would benefit from when they're kind of going back and thinking about what radian measures are, because we use them a fair amount in upper level math. One radian measure is about that much. So there's a radius. So let's say that radius we're able to make perfectly bendy and bend around the outside. There's 6.28 of those pi pieces we can fit in. So 6 of them plus a little bit more of a pi piece that make up a whole circle. So you think about, well, how many degrees would that be? Well, let's see, how many degrees would it be? Well, let's say if we did an unknown amount of degrees divided by 360, so part divided by whole, equals, we just said we did one radius length, and we know there are 2 pi of them in the circle. So again, think part divided by whole. So part over whole. So you do degree part over whole, and you do radian part over whole. And then to solve, you would just multiply both sides by 360. So it'd be 1 times 360 divided by 2 pi, and that number is going to tell you how many degrees are in a single radian. So 1 divided by 2 pi times 360. So we'll do 1 times 360, which of course is 360, divided by, and then I'm going to use parentheses here so I get my 2 and the pi being divided, and I hit enter. And that's 57.3 degrees. So you think, okay, here's my question mark. I should get that in there. My question mark then would be 3 degrees. So 57.3 degrees. So if you think about it, there are 6 of those, 57.3s, and then a little bit more. If it was exactly 6, it'd be 60 degrees. So it should be pretty close to 60. And again, the whole idea there is this is just a different way to measure an angle. It's saying how many of the bendy radius amounts can we fit around the outside? We can fit 2 pi of them. That's where this fraction comes into play. 2 pi divided by 360. That's just taking the total number of radians in a circle, or radius amounts, divided by 360. And I think an easier way to think about these, and I'm going to propose you solve it this way, is to just keep along these part divided by whole situation. And I'll show you what I mean by that. So let's do our 2 examples they gave us. Convert 60 degrees to radians. So what I like about the part divided by whole is I've already been using it, and I don't need a special equation. I just say, okay, part 60 divided by whole 360 equals part, which I don't know, divided by 2 pi. You're always going to have the 360 and the 2 pi on the bottom. Those are always the wholes. There's always 360 degrees, and there's always 2 pi radians. And then you're going to be given one, in this case the 60, and you're going to look for the other one. It's why I really like this fraction method that the book doesn't use, but it works, and it's, I think, really effective, because now to solve it, you're just going to say, well, okay, multiply both sides by 2 pi. So I've got 2 pi times 60 divided by 360. Pop over to the calculator. We've got 2 times pi times 60 divided by 360. And we hit enter, and that's 1.047, or let's call it 1.05 radians. I don't like to keep it to 0 because it's not exactly 1. So I know we usually go tenth, but let's say 1.05. So we'll say, oops, say our question mark is 1.05 radians. And what I like about that is we're converting it into radians. Now, it is possible, depending on the way an answer gets put into a textbook, and it totally depends on the textbook maker. You can ask to round it, or you can do 60 times 2 pi divided by 360, and you can algebraically solve this. So we could do 60 times 2, well, that'd be 120 pi over 360. And then that's a fraction where 120 and 360 can both be reduced. You can divide 120 and 360 both by 120. So you reduce the fraction and you end up getting pi over 3. And that's just fraction reduction. If you have a fraction of 120 over 360, that's the same as 1/3. So if we take 120 pi divided by 360 and reduce it, you get pi over 3. Pi over 3, if we pop that into a calculator, better give us 1.05. And let's just make sure it does. So let's do pi divided by 3. Hit enter, and sure enough, those numbers match up perfect, which they should. So these two mean the same thing. And depending on how the textbook wants you to express it, you could express it either way. If you're asked to round it, you use a decimal. And if you're just asked to leave it in kind of non-rounded form or exact form, this sometimes gets called, you can just leave it this way as the pi over 3. Yeah, so let's do this last one. So convert 5 pi over 6 radians to degrees. So we'll say, okay, well, let's see. 5 pi over 6 radians to degrees. Well, we've got degree part, we don't know, divided by 360, which is the degree whole. And then we've got radian part, which is 5 pi over 6 divided by 2 pi. So to solve this one, I'm going to multiply both sides by 360. And again, what I like about that, 360 and the 2 pi, always there, always on the bottom. And then you're just figuring out which one of the other top pieces do I want. So then we have question mark equals, and there's a lot of fractions going on. So 5 pi over 6 times 360, all divided by 2 pi. And this gets a little bit tricky. So we can plug all this into a calculator. We can do 5 times pi divided by 6 times 360 divided by 2 pi. Let's try that. So I'll clear all this out. So 5 pi divided by 6, we'll hit enter. And then we said we're going to multiply that by 360. And then we said we were going to divide that by 2 pi. Divide that, I'll put my parentheses just to make sure I'm getting the whole 2 pi divided in there. Hit enter. And I've got 150. That sure looks like it'd be a nice number for us, doesn't it? So 150 degrees. So 5 pi over 6 radians is equal to 150 degrees. And I know that's a lot of fraction stuff to hold on to and to keep straight, but your calculator can do it if you just are careful in the keys that you press. And again, what I would say is use the part over whole idea that we did in the first video, and you can do that in this video as well. So you just do, again, the overall setup was the unknown amount of degrees divided by 360 equals the radian amount divided by 2 pi. And you're just filling in one of these two spots, and then you're finding the other one, and the 360 and the 2 pi are always there. So that's it. That is how you convert from degrees to radians, or how you go from radians to degrees.